Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburo. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. As indicated, today we're going to revise paper 2, chemistry. So I felt that it's important that we first look at how the learners have been performing in this topic in the previous year. You will have seen that here, question 1, learners were performing at 51. Remember, question 1, we're talking about multiple choice questions. So learners were performed at 51%, question 2 at 65%, question 3 at 60. Remember, question 2 is your naming and isomers. We refer to it as nomenclature. And then question 3, that is your physical properties. Remember, learners, we do 3 physical properties, which is your melting point, your vapor pressure, and your boiling point. And then in question 4, we're talking about reactions of organic molecules. Learners performed at 49%. You can see the performance in terms of reactions goes down. Question 5, which is the rates of reactions, is at 47%. Question 6, which is at 52%. That is chemical equilibrium. And then question 7, 41%. That is acids and bases, 41%. But look at question 8, which is your galvanic cell. The performance was at 27%. You can see a huge drop there in terms of galvanic cells. I know you have done them not long ago. You still remember them. We'll definitely prioritize galvanic cells. We'll prioritize as well question 9, which is your electrolytic cell. This is the last question of your paper, and most of learners don't really do well in this last question. So we'll ensure that after this, you must be even more confident to go and write these questions or come Monday. On average, learners performed at 49%. So we're going definitely to look at the marks per topic to say, if you look the structure of the paper, we are saying we have 10 multiple choice questions as indicated, just like you did with your paper 1, and the marks there is 20 marks, which is about 18% of your paper. You have 130 marks that will come from structured questions. The paper will still be 3 hours. And matter and materials, we are referring here to your organic molecules. So you can see organic molecules, we are talking about 58 marks. So it's a lot of marks that if you do well in terms of organic, and then you can be able to come with that 58, and it is possible. So it is the aim of this live broadcasting to ensure that you have understanding of getting that 58 marks, then you are able to pass. And then in terms of chemical change, remember when we talk chemical change, you are talking about from question 5, which is your rates of reactions, chemical equilibrium, acids and bases, galvanic and electrolytic cell. So those 5 topics will give you 92 marks. So you can see a lot of marks. If you get out of 58, you can come back with 50. Then you have done well. Then you go to the other remaining topics, you have 92. Then you are able to get as many marks as you can so that you are able to get those distinctions. And we are saying the total for the paper is 150 marks. You'll be writing on the 15th of September 2025, and then it will be marked at your school. Now, the first topic, without wasting time, which is our organic molecules. As indicated, we are going to start with nomenclature, which is your naming of organic molecules. I hope by now you must be having confidence in terms of naming of organic molecules. So we'll look at that. Our focus would be on skills, so that whatever you are given, you are able to name. It doesn't matter what question is about. As long as you say name, write down the IUPAC name of an organic molecule, you must be able to name that organic molecules. We'll as well look at isomers. So we'll do naming and isomers as well. And then we'll look at physical properties. I've already indicated that we focus on 3 physical properties, which is your melting point, your vapor pressure, and your boiling point. So those are the 3 physical properties that we do. So we're going to look at the factors that affect these 3 physical properties, and then we're going to look at that, and then we're able to move. So I hope you will, when we leave this lesson, you'll be happy and be able to go and write question 3 and get all the marks that you can collect. Nothing is difficult here. You just have to have a conceptual understanding. And then we're going to look at organic reactions. Now, it's very much important when you look at reactions of these organic molecules. I think it's of importance that you check which organic molecules undergo which type of reactions. You will remember our organic molecules is made up of only 9 homologous series. So we have 9 homologous series, which is your alkanes, alkenes, and alkynes. I always refer to them as AAA, which is your alkanes, alkenes, and alkynes. And we refer to them as hydrocarbons. So those are our hydrocarbons. So it's important that we have that. And then we have what I refer to as Hake. And then your Hake, we're talking about your haloalkanes, your aldehyde, your ketones, and your esters. And then we have the last two, which is your alcohols and carboxylic acid. So you can see we have 9 homologous series that we are going to focus on. In terms of grade 12, those are the only 9 homologous series we have to know. So alkanes, alkenes, alkynes, haloalkanes, aldehyde, ketones, esters, alcohols, and carboxylic acid. And we're saying when it comes to reactions, organic reactions, it's very much important that you understand which homologous series will undergo which reactions. So we're going to look at that to say if we're having this type of homologous series, which reaction will they undergo. And I will want to advise you to give a special concentration to your those three, your alkanes. I refer to them as AHA so that you don't forget. That is your alkanes, your haloalkanes, and then your alcohols, haloalkanes and your alcohols. You will see that most of reactions are around these 3 homologous series. So it's very much important to understand that when I see an alkane, when I see a haloalkane, when I see an alcohol, which reaction will they undergo? So we're going to look at that. Hence, I'm emphasizing there to say always have that in your mind. To say when I'm having alkanes, when I'm having haloalkanes, when I'm having alcohols, what type of reactions? You will see that all of them, they can undergo what we refer to as substitution. So when you see alkanes, haloalkanes, and alcohols, you know that they can undergo a substitution. And all of them can undergo eliminations. They can all undergo elimination. So it's very much important. You will see that most of the questions that we'll have under reactions will be based on this AHA that I'm referring to, or your alkanes, haloalkanes, and alcohols. They will definitely undergo substitution. They will definitely undergo elimination. And then we want to emphasize the issue of reaction condition. Remember, for a reaction to take place, the condition must be met. I know you have done rates of reactions. You know that there are conditions for a reaction to take place. You said there must be correct orientation. There must be enough kinetic energy. Even in terms of these reactions, it's the same thing. We are saying now there are reaction conditions. So know the reaction conditions, and then they will be able to tell what type of reaction will take place. So I'm emphasizing that as long as you want to get many marks in this topic, you will definitely understand the reaction condition. I think I've emphasized that enough, and then you understand the importance of reaction conditions. If you know reaction conditions, you will know the type of reaction that will take place, and then that will definitely help us. Now, in terms of question 2, we are saying we have these definitions that you must know. I know by now you must be singing all these definitions. You know, for definitions, we are saying you must know them according to the exam guideline so that you get all the marks that are allocated. For example, the first definition there that I gave there is homologous series. To say what are homologous series, you remember you are saying it's the series of organic molecules that can be described by the same general formula. They can be described by the same general formula. Or you can say each member differs from the next by the CH2 group. So you will talk about that as you define homologous series. And then you must be able to define as well the functional group. Remember, we're saying this one are the centers of reaction. These are the centers of reaction. When we talk about physical properties, which is your melting point, boiling point, and vapor pressure, they will definitely depend on the functional group to say in which family do you belong, because how the homologous series is going to behave is going to depend on the functional group. So functional groups are important, and we are saying these functional group are these are the bonds. Remember, we have alkene, that is a double bond. We have an alkyne, that is a triple bond. So you see that a functional group can be a bond, and then it can be an atom. It can be an atom, can be a bond or an atom, a bond or an atom, and then it can be group of atoms as well. They are able to indicate a functional group. So that back is just for you to remember that it can be a bond, can be an atom, can be group of atoms that determine the physical and chemical properties. Physical, question 3. Chemical, question 4. So we're saying how the reaction, how the homologous series or how organic molecules will, how fast they boil or how slow they will boil or how high their boiling point depends on the functional group. So it's very much important. And we are saying a functional group is a bond, it's an atom, it's a group of atoms that determines the physical. Question 3, it determines the physical and chemical. Chemical is question 4, the reactions, how they react. It will depend as well on the functional group. So we're saying it's a bond, it's an atom, it's a group of atoms that determine the physical and chemical properties of an organic molecule. So you are able to get that definition as well. Remember, when I started, I said AAA, we're having our hydrocarbons, alkanes, alkenes, and alkynes. Please don't forget that as you prepare yourself for this topic. Alkanes, alkenes, and alkynes. These are hydrocarbons. Why do we call them hydrocarbons? We're saying these organic molecules are made up of hydrogens and carbons only. Hydrogen and carbon atoms only. So it's only hydrogens and carbon atoms only that makes up a hydrocarbon. And we're saying these hydrocarbons, they can be saturated or unsaturated. So the hydrocarbons can be saturated or unsaturated. So you are able to know that when we say they are saturated, we are saying they have no multiple bonds between carbon atoms. Please, always let's use the definitions from the exam guideline. When we say saturated, we are saying they have no multiple bonds between carbon atoms. When we say unsaturated, your alkenes and alkynes, they are unsaturated, which means that they have a double bond between carbon atoms. So be able to differentiate between saturated and unsaturated. And our exam guideline has made it much easier because we're saying saturated have no multiple bonds between carbon atoms. Unsaturated have multiple bonds between carbon atoms. But don't make a mistake of just saying saturated, they have single bonds and you leave it there. Unsaturated, they have double bond or triple bond and leave it there. No, you must be able to say they have no, saturated have no multiple bonds between carbon atoms. Underlined the between carbon atoms because that double bond must be between carbon atoms for it to be unsaturated. The double bond or triple bond must be between carbon atoms. Now, when we are done with that hydrocarbons, which is your alkanes and alkynes. Remember, alkanes are saturated, which means they have no multiple bonds between carbon atoms. Now, we're going to look at the isomers. And for isomers, we are saying these are structural isomers. They have the same, iso means same. They have the same molecular formula, but different structural formula. So with that, we're calling them structural isomers. And then we're saying we have 3 types of structural isomers. We have 3 types of isomers, which is the chain isomers, the positional isomers, not position, but positional isomers, and the functional isomers. So these are our isomers that we are having. To say now, always these are organic molecules. So you will just say they are organic molecules with the same molecular formula. All of them, isomers, they have the same molecular formula. What is different? For chain, the different chain length. So different chain length or different types of chains for chain isomers. And then for positional isomers, same molecular formula but different position. Please remember the different position is three things that have different position. I know that you might be used to say they have the same molecular formula but different functional group. No, you must mention all the three of them. They have the different position of the side chain, of the substituent, and of the functional group. Please write the correct definition according to the exam guideline. So please ensure that for positional isomers, we're saying the organic molecules have the same molecular formula but different position of the side chain, of the substituent, and of the functional group. Please, SSF, remember always that. Now, and then you will see that the chain isomers and positional isomers are within a homologous series. So when you have the same homologous series with different chain length, you know that we are talking about chain isomers. When you have the same homologous series with the different position of either the side chain, the substituent, and the functional group, we're talking about functional isomers. And then, we're talking about positional isomers. When it comes to functional isomers, they belong to different homologous series. So the homologous series are not the same. So we're saying these ones, they have the same molecular formula but different functional group. They have different functional group. And we gave you cake there for you to always remember to say these ones is between the aldehyde and ketones, the carboxylic acid and esters. I hope this helps you as you remember the definitions, because definitely you will get questions that want you to define. I think I've laid the ground. We can go now and look at questions to say how do you go about answering questions. For example, this one is saying which one of the following is the general formula of alkanes. Now we have 9 homologous series. The expectation is that you must know all the 9 general formulas for those 9 homologous series. Please ensure that you know all of them. We had alkanes, alkenes, alkynes, haloalkanes, aldehyde, ketones, esters, alcohols, and carboxylic acid. And we are saying to you, know for alkanes, for example, know that alkanes is CnH2n plus 2. So we have everything. That is the richest one. If you look at alkanes, they have maximum number of carbons and hydrogens. And then when it comes to alkenes, we are saying now for alkenes, we're going to remove 2 hydrogens to form alkenes from alkanes. Then definitely it will be CnH2n. And then for alkynes, we remove another further 2 hydrogens. Then it becomes CnH2n minus 2. Haloalkanes, we are removing, or we are substituting one hydrogen. You know the reaction substitution. When you substitute one hydrogen by a bromo or a chloro, a group 17 element, so you get a haloalkane. These are alkanes of special kind because they have halogens. So it's a haloalkane, and then we're saying a haloalkane, it will still be CnH2n plus, but it won't be plus 2 because we are removing one hydrogen. So it will be plus 1, and then where the halogen is, we put X. Remember, X stands for halogens, hence we call them haloalkane. So you just look at the alkane, CnH2n plus 2, you remove 1, then we have CnH2n plus 1, then you put X for halogens, and then that is our haloalkanes. And then when it comes now to our aldehyde is now CnH2nO. So you can see that we are removing 2 hydrogens from the alkanes. We are putting 1 oxygen, which shows you that there must be C double bond O there. There must be C double bond O in aldehyde. And then ketones as well. Ketones, it will be CnH2n. Don't forget the N there. Is CnH2nO. So you can see that the general formula for aldehydes and ketones, it is the same. Definitely is a message to yourself. Hence, we are saying aldehydes and ketones, they are functional isomers. As long as they have the same molecular formula, they will definitely be functional isomers, because you can see that. And then we have what we refer to as esters. And for esters, so we are saying now we're talking about now 2 oxygens, CnH2nO2. The same with carboxylic acid is CnH2nO2. So what am I saying? I'm saying that alcohols, they have CnH2n plus 1 OH. Don't forget the 1, because learners just write OH and it becomes wrong. So those are general formulas, and definitely the expectation, you know all of them, because one of them, if you find any question that want you to use that, you are able to do that. Remember, when we give you the number of carbons, you can come and substitute N there to get the molecular formula, so you are able to move like that. I hope that helps you and reminds you, because this is the foundation that you are building these organic molecules on. So if you don't know the general formula, which is now the basic, the building block in terms of these organic molecules, you'll have a problem. Make sure that you understand all those general formulas. And then the question was for alkanes, and then we know that for alkanes it must be CnH2n plus 2. So CnH2n, we said, is alkenes, because we have removed 2 hydrogens from the alkanes. CnH2n minus 2, we said, is alkynes. And then CnH2n plus 2 definitely is an alkane, is saturated. And then CnH2n plus 1 OH. So you can see there you have your alcohol. So you are able to know all the general formula. I've emphasized that as I move. I hope you have that, and you will definitely go to the exam with all the general formulas. Now, for question 2 there is about functional groups, because as well, you know the general formulas. The expectation is that you must know all the functional groups. These functional groups, some have names, and then the ones that have names are the ones that are in this question. So this question, I like it because it's showing you that these are the functional groups that have names, and the expectation will say write down the name of the functional group. Now the question was name of the functional group of alcohols. So this question is based on alcohols. And then you are able to come and check this one. A is carboxyl group. You can hear from the name carboxyl, it means it's a functional group for carboxylic acids. So we just took the carboxyl there. And see, all the functional group have a group because they are groups. We call them functional group, which means for carboxylic acid, you will call it carboxyl group. For carbonyl, you have carbonyl. Carbonyl, we have it in ketones. I usually call them the ketones. And then you are able to say, okay, carbonyl, will get it in ketones. And then formyl group, you are getting them in aldehyde. Please know all the names of these functional groups. For aldehydes, we call them formyl or formyl group. Hydroxyl group for alcohols. Now, the other question that you can be asked there is to say, draw the structural formula of the functional group. So you must be able to know how to draw the structural formula. Structural formula means show all the bonds of the carboxylic group. So you must be able to show the C double bond O with an OH. Remember, carbon must have 4 bonds around it at all times. Please don't forget, all the time for carbon, there must be 4 bonds around it. We said it's tetravalent, it's group 14, so you know definitely that it must have 4 electrons there. Now, again, the other thing which is important is the oxygen. That oxygen at all times must have 2 bonds around it. Carbon, we're saying all the time 4 bonds. Oxygen all the time 2 bonds. So when you're throwing oxygen, it will always have 2 bonds, and the hydrogen will always have 1 bond. So don't forget that. So when you are drawing your carboxyl group, definitely your carbon, ensure that it has 4 bonds around it, and it has a C double bond O and an OH. I usually refer to it as Cu, so that you always remember. And we are saying the name of this functional group is called carboxyl group. For ketones, we said the name of the functional group is called carbonyl. And the carbonyl, when you draw it, it's a C double bond O, but this C double bond O is surrounded by 2 carbons. It must be between, for ketones, it must be between 2 carbons. For aldehydes, it must be a C double bond O again. So you can see what is common here, C double bond O. And then this C double bond O must be followed by the H there. So you can see there that now is no longer between two carbons, is on the terminal carbon, it's in carbon number 1, the C double bond and an H, and always the carbon must have 4 bonds. Please know how to draw this structural formula. Many exam question papers have that question. Now alcohols, there are learners who make a mistake of thinking that alcohols are OH. Alcohol, the functional group is not OH, but the functional group is the carbon bonded to the OH like that. So please, when you say draw the structural formula of the functional group for hydroxyl group for alcohols, definitely it must be carbon. So you can see there is something in common. All these functional groups, they have carbon. There must be carbon and then the other part of the functional group. So this is what we refer as hydroxyl group, the functional group, and this is the structural formulas. I hope this assists you as you go on with the questions, and then you understand. Now, here the question was about alcohols, and already we said that's how we draw it, and alcohol is hydroxyl group. And you can see is hydr from hydrogen with what? With oxygen. So you can see hydroxyl group. I think it helps you now to see that, okay, it's a hydroxyl group for alcohols. Now, as we move, because we want to do as many questions as we can, we are saying which one of the following pairs of compounds are functional isomers. When you see functional isomers, you always remember cake, that we have the carboxylic acids and esters. We have the aldehyde and ketones. And remember, carboxylic acids and esters, they have 2 oxygens. So it's CnH2nO2, CnH2nO2. So I always emphasize this EC, some they say Eastern Cape for them to remember. EC, you know that it's for esters and carboxylic acid. They have 2 oxygens in them. So when you see 2 oxygens within a structure, you know it's either an ester or a carboxylic acid. And we are saying for a carboxylic acid, the C double bond O and the OH is in carbon number 1. So it's easy to identify carboxylic acid because the C or the C double bond OH will be in carbon number 1. But for the ester, the C double bond O and another oxygen will be surrounded by those carbons there. So you are able to see the difference, to say this one's C double bond O and an oxygen must have carbons around. But for carboxylic acid, it's a C double bond O and an OH. So the H there that is bonded to the hydrogen is the one that is showing you that this is a carboxylic acid. So all the time, remember EC, they have 2 oxygens and can only be esters and carboxylic acid. And then we are saying the structures that have 1 oxygen is your alcohols, your aldehyde, your ketone, and alcohols. These ones, they have 1 oxygen. So you can see already that at least you have understanding. When you are seeing a structure with 1 oxygen, it can only be aldehyde, ketone, or alcohols. And then the ones that are made up of hydrogens and carbons only, hydrocarbons, we said is alkanes, alkenes, and alkynes. So you are able to differentiate amongst all the structure. And I think we have 3 here that are hydrocarbons. We have 3 that have 1 oxygen, and we have 2 that have 2 oxygens, and we have haloalkanes, which is said is those are alkanes that have been substituted with a halogen, and then we refer to them as haloalkanes. Now we're saying which one of the following pairs of compounds are functional isomers. Already you check, you know what you are looking for is either you are going to find a carboxylic acid and ester, aldehyde, and ketone. So you check methanol, alcohols, no. Methanol, aldehyde, but not with an alcohol. Butane and 2-methyl propane. You can see there we have 4 carbons. This must be chain isomers. This must be a good example of a chain isomer. Same molecular formula but different type of chain, unbranched and branched. This one, butane is unbranched, and then 2-methyl propane is branched. Now propan 1-all and propan 2-all, you are able to look there and say these are positional isomers. Remember, the good thing about chain and positional isomers is that all these two, the 2 isomers must belong to the same homologous series. So when you see that they belong to the same homologous series, it's either chain isomers or positional isomers. And with these ones, you can see they are all anes, belong to the same family of alkanes. then you know definitely that these are chain isomers. And then when you see propan 1-ol, propan 2-ol, we are changing the position of the OH. We are changing the position of the functional group. And then we are able now as well to talk to the issue of primary, secondary, and tertiary alcohols or haloalkanes. So we can talk about primary alcohols, secondary alcohol, and tertiary alcohols. And we are saying our primary alcohols, you see this propan 1-ol, you will see if you were to draw it, you will see where the OH is in carbon number 1. So you can see that the carbon that is bonded to the OH, the carbon that is bonded to the OH, remember, OH is not the functional group. The functional group is carbon bonded to the OH. So be careful of your language there. I'm saying the carbon that is bonded to the OH is bonded to one other carbon. That is a primary alcohol. But if I was to move the OH to carbon number 2 in propan 2-ol, OH is in carbon number 2 like that, then it's no longer now a primary alcohol. It's now going to be referred to as a secondary alcohol. Why? Because the carbon that is bonded to the OH is bonded to 2 other carbon. And you can see with the tertiary alcohols as well, when we move now the OH, the carbon that is bonded to the OH must be bonded to 3 other carbons. So you see the difference now. We are always looking at the carbon that is bonded to the OH. Or you can say the functional group, which is your COH, is bonded to 2 other carbons. So that's the different ways of saying it. And then you can now differentiate between primary, secondary, and tertiary alcohol. So we're saying propan 1-ol will be our primary, propan 2-ol will be our tertiary. And then definitely if we have another branch, we can be able to get our tertiary alcohols. Now the question was, which one is a functional isomer? And then we said we're looking for carboxylic acid and ester, or aldehyde and ketone. And if you check, propanoic acid is a carboxylic acid. Methyl ethanoate is the ester. So you are able to see that this must definitely be our functional isomer. They have the same molecular formula, but different functional groups. All of them, O2, O2, all of them have 2 oxygens. And then it's those ones I was saying, Eastern Cape, I was making to remember esters and carboxylic acid as we move. Now, the whole of chemistry is based on this one called periodic table. This one, you must treasure that the periodic table is everything that we need. Now, I wanted here to indicate to yourselves, to say, remember we talked about substituents like fluoro, chloro, bromo, and iodo. These group 17 elements here. And we were saying, when we talk about positional isomers, we said these substituents, they can be in different positions. You have seen the substituents can be 2-chloro, propane, and chloropropane. They will definitely be positional isomers. So you are able to see that these are our substituents. But these are not the only substituents. So I want you to be able to come to the periodic table and write me there, which is now methyl, ethyl, fluoro, chloro, bromo, and iodo. All those are your substituents. Those are your prefix. When we're going to do naming of organic molecules, we are saying all of these, we're going to treat them the same. They are all substituents, and the name will always start with them. As long as there is a methyl, there is ethyl, there is fluoro, there is chloro, there is bromo, there is iodo. The name must start with them, and we must always arrange them in alphabetical order. So I'm saying to you, the preference of methyl, which is CH3 like that, the preference of CH2, CH3, which is your ethyl, is the same with the preference of fluoro, chloro, bromo, and iodo. No, we prefer them the same. We treat them, all of them, as substituents, so that you don't have a problem when you do our naming of organic molecules. So it's me, FCBI, for you to remember is methyl, is ethyl, is fluoro, is chloro, is bromo, is iodo. All those are our substituents, and when they are in the structure, the name will always start with them in alphabetical order, and we indicate even the number where we find them in the structure. So I hope I've clarified that one, because now we are going to naming and you will always remember what we said. Now, as we consolidate equation 2, we are saying the letters A to E in the table below represent 5 organic molecules. So we're given the 5 organic molecules, and then definitely the questions that you are expecting, the FH gemsine there, not for decoration. To say the F there, you must know the functional group which they belong. You must know the homologous series. The H there is the homologous series. The questions will be about that. Which homologous series does A belong? What is the functional? Draw the structural formula of the functional group of A in that order. General formula, the GE there is for general formula. To say you must know the general formula for all of them. You must know the molecular formulas. You must know the structural formula, condensed structural formula. I can't emphasize this better. You can see most of our questions now, they have condensed structural formula. So practice as many condensed structural formulas as possible, because they can be confusing at times. And then isomers and naming, which is IUPAC naming. So you can see the F functional group, the H homologous series, the general GE for general formula, M for molecular formula, S for structural formula, C for condensed structural formula, I for isomers, and N for naming, which is IUPAC naming. So those are the questions that you're expecting in this section. And we are saying as the strategy, definitely when you look at that structure, you will check what is the functional group. That is the first thing you ask yourself. What is the functional group? You can see we have a substituent called bromo. We have another substituent called CH3, another substituent called CH3. So you can see I'm treating CH3 and bromos the same as substituents, because I've already emphasized the me FCBI there to say these ones, we're going to treat them the same in a structure. But now, if we never had a bromo here, this would be an alkane, definitely. But because we have a bromo, which is a halogen, it changes the name now to a haloalkane. It's a haloalkane, but halo, we're taking it as a substituent. The same way we are going to treat halo is the same way we're going to treat CH3 and CH3. So if they were to ask you to name this particular structure, definitely you're going to say, when you name, the emphasis is here to say we have the suffix, which comes from the functional group. We have the root, which is the longest carbon chain, and we have the prefix, which is the substituent. So always the name will start with substituents, and I've emphasized for you prefix substituents is this one's me FCBI, which is our methyl, our ethyl, our fluoro, our chloro, our bromo, and our iodo. As we name, those are the ones that will always give preference. The name will start with them. The root is the longest carbon chain. We're going to look at the longest carbon chain. The suffix is the functional group. So which family does this belong to? You said it's haloalkane. Definitely they belong to the family of alkanes. So it's an ane. That is the suffix. Ane is the suffix of haloalkanes. So it's an ane. Root. How many carbons do we have in the longest carbon chain? So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it's hex. So you're able to say it's hex. So it will be hexane. But do you have visitors? Yeah, definitely. We have a visitor from the right. We have a visitor there, which is bromo. From the left, we have a visitor that is methyl. And I told you that these ones, we are referring to them as substituent. We're treating them the same. So carbon number 2 doesn't help us in terms of naming, because in carbon number 2 from the right, we have a bromo. Carbon number 2 from the left, we have a methyl. Hence, we'll go to carbon number 3 to say, let's go to carbon number 3. Maybe it will show us a clear picture to say, where must we start numbering, from the left or from the right? When you start from the right, carbon number 3, this one, there is nothing. It's only hydrogens. But carbon number 3, from the left, there is another CH3. So definitely you can see that from the left, we have the mostly substituted side. So we have more substituents on the left-hand side as compared to the right-hand side, irrespective of bromo being being in terms of alphabetical preference, bromo being B. Definitely when we prefer, the first thing we prefer is the functional group. Number two, we look for the mostly substituted side. And the mostly substituted side is the left. So this is carbon number 1, number 2, number 3, number 4, number 5, number 6. I hope I've clarified the issue of bromo and chloro belonging to this family, to say we are treating them the same as substituents. And then we are saying we are starting from the left because on the left we have the mostly substituted side. I think I've emphasized that. We have moved together. So you are able now to see that, okay, in terms of the naming, we'll definitely have bromo is in carbon number 5. So definitely this structure will be 5 bromo, A, B, C, D, when we're writing the name. In carbon number 2 and number 3, we have methyl. So that is 2,3 dimethyl. 2,3 dimethyl hexane. Remember, the name is one name. You see, I've never used any capital letters there. Just write small letters, name. Don't forget, unlike terms, a letter and a number, there must be a hyphen. A number and a number, there must be a comma. So like terms, comma, unlike terms, hyphen. Please have that in your mind. And one name is only esters and carboxylic acid that will have space between the name, like your hexanoic acid, methanoic acid. There is space between the hexanoic and acid, but all the other homologous series is only one name. No matter how long it is one name. I hope this will help you as you do lot of naming questions. And we are saying, when you get a structure that is given as like that, as a molecular formula like that, C3H8O, please first draw it. You will be so amazed when you look at it. You can see something, can't you? When you draw it, you find that it's different. Remember, when you see 3 saying draw 3 carbons, and then these 3 carbons, there are 8 hydrogens. So you allocate the hydrogens. Remember, each carbon must have 4 bonds. So it's 3, 4, 5. And then you are able to see 6, 7, OH, number 8, hydrogens, there are 8. So you can see it's an alcohol. But without drawing it, you can make a mistake of thinking maybe it's an aldehyde or a ketone or something. So please draw it in order for you to know definitely that this must be an alcohol. And then on this one, you can see we are having an ester there. We are having an ester. And I'm saying, please remember the process esterification. We are saying that always formed from an alcohol. In this case, we're using primary alcohols plus carboxylic acid. And then we're saying alcohol plus carboxylic acid form ester and water. And we're saying when you see water, know that sulfuric acid, which is our dehydrating agent, sulfuric acid will be our catalyst. So always have that, and heat as well will be very much important. So know that we are having an alcohol. The alcohol will always, the alkyl part, you can see that this part that is the C double bond O will always come from the carboxylic acid. So the one that is have a C double bond O will be coming from a carboxylic acid, and the one that is an alkyl group without a C double bond O this side will come from an alcohol. Because the question can be this ester, was formed from which organic molecules? So you're able to see, okay, this one is an alkyl group, the one without the C double bond O, you see that must be propyl, and propyl is from propanol. So you can see that we had propanol, and we have 1, 2, 3, 4 carbons. So the acid was butanoic acid. And we are saying, don't forget the conditions. We are saying sulfuric acid and some heat there. And then we are saying this will give you propyl butanoate. And we said there is a space, 2 names, propyl butanoate. And then you are rolling. You are able to do all that, and then you are getting all your marks. Definitely expect a question on esterification. So you can't go to the exam without having that understanding. I hope all these have shown you what is to be expected of you in terms of question 2. Now, when we look at our physical properties, remember I've emphasized here that we have 3 physical properties, which is your melting point, vapor pressure, and the boiling point. I put them intentionally in that order because we're having a solid that must become a liquid until it boils. Now, our melting point, we said it's not a point, it's a temperature at which the solid phase and liquid phase are at equilibrium. Solid phase and liquid phase are at equilibrium. So we have two equilibriums here, the one at for melting point and the one for the vapor pressure. Remember, vapor pressure was saying is the pressure exerted by vapor at equilibrium with its liquid. So it's a pressure exerted by vapor at equilibrium with its liquid in a closed system. For this one, you must say closed system because the molecules now have higher kinetic energy and can escape if we don't close the system. So it must definitely, this one must be in a closed system. So we have the first equilibrium where we don't mention closed system. Second equilibrium of vapor pressure, we mention it. And we are saying now boiling point is a temperature gain at which this vapor pressure that we're talking about now is equal to atmospheric pressure. So it means the vapor pressure increases until it reaches atmospheric pressure. Remember, atmospheric pressure, we said is 101.3 kilopascals. It is given on your table, and then you are able to have that. And then we are simply saying your water will boil or your molecules will boil when the vapor pressure is equal to 101.3 kilopascals. Remember, we can use 101.3 kilopascals or we can use 180 M. So those are three physical properties. And then for this lesson, I will want to minimize the number of independent variables that we're going to have, factors affecting three physical properties. We have three physical properties, and we're saying there are factors that affect them. And the factors that are for this lesson I want to focus on is your intermolecular forces. To say intermolecular forces definitely. And for our syllabus, you'll see that if we change the functional groups, you find that we are changing the intermolecular forces. So I will restrain it to intermolecular forces as the first factor that will affect these physical properties. And then we have now again our chain length. We have our chain length. As the chain length increases, the boiling point and the melting point will increase. Why? Because the strength of intermolecular force increases. And then we're going to look at the branches to say as the number of branches increases, the strength of intermolecular forces decreases. Hence, you'll have as the branch increases, you'll have a lower boiling point and melting point. And don't forget that if you were to deal with that, you definitely, if you have more branches, you're expecting that now you have the highest vapor pressure, because vapor pressure increases as the strength of intermolecular force decreases, whereas melting point and boiling point increases with increase in the strength of intermolecular force. We're always emphasizing here, don't use directly proportional. Just say as the melting point, as the strength of intermolecular force increases, melting point and boiling point increases. As the strength of intermolecular force decreases, vapor pressure increases. Have that and refrain from using directly proportional. So I hope I've summarized it nicely for you. And then already we said we are dealing with the independent variable and dependent variable. The independent variables, those are our independent variables. Our dependent variables are the three physical properties, which is melting point, boiling point, and vapor pressure. If you get a question that says, what is the dependent variable, is either melting point, boiling point, and vapor pressure. In this case, our dependent variable will be boiling point. Our independent variable, what are we changing? We are changing the number of carbon atoms, which is our chain length. So you are able to see that that is the case. And then as well, when we move here, we're able to check as well the independent variable changes as it changes, and then the dependent now there will be effect. As long as we change the other factor, the factors that affect the physical properties, definitely there will be effect that will have there. For an example here, we're given number A. Look at A there. we are having that structure, which is 1, 2, 3, 4, 5. We're having pentane. We're having 2 methyl butane. We're having 2,2 dimethyl propane. So definitely you can see we're increasing. We're increasing as we move from A to B to C. We're increasing. These are the trends. We're increasing the number of branches. What is the effect of increasing the number of branches? As we increase the number of branches, the vapor pressure increases. And you know definitely that vapor pressure increases with the decrease in strength of intermolecular force. I'm always emphasizing that one so that you don't make mistakes. Now, in terms of how you are going to answer questions, we are saying the main thing, you have to explain the difference. So I usually will say here, you can just use what we call dice for you to remember. The dice there, I'm simply saying look at what is different, and then look at the strength of intermolecular force and the energy required. So we're saying look at what is different, and then what is different, we said, is our independent variable, what is changing. And you look at the strength of intermolecular force. Is it stronger or weaker? Intermolecular force, write it in full. And the energy required to overcome the intermolecular force. So if you have all that, you are ready to go. You can answer any question because you can be able to show for A and for B, and then you are able to answer the question to say, okay, what is the AB? Let me write it here. What is the difference? Remember, on the difference, you are restricting yourself to your intermolecular forces, your chain length, and your branches. And then you are able to say, what is different? This one has a longer chain length. This one is a shorter chain length. What is the strength? Then you are able to say the one with the longer chain length has a stronger intermolecular forces. The one with the weaker, with a less, not a shorter chain length will definitely have a weaker strength of intermolecular force. And when it comes to energy, if the strength of intermolecular force is high, definitely less energy will be required to overcome the intermolecular force. So if you have that dice table there, you are able now to go and answer this question. And we're saying you can do like that, or you can do in bullet forms. What helps with bullet forms is that we will definitely look at those bullets independently. So that if you are writing a paragraph, you are explaining a wrong concept, everything is wrong. But when you are writing in bullet forms, we'll read the bullets like that. And always look at the number of marks, because it will tell you how many points we're expecting for the question you are answering. I hope this helps you as you answer questions. And then to look at an example here, to say we're given 4 compounds A to D. We have your propane, your butane, your butanol, and your butanol. So it's very much important for you to have that understanding there. The first question was define the term melting point, and already we've emphasized that melting point, we're talking about equilibrium. We said it's the temperature at which the solid phase and the liquid phase are at equilibrium. And then we're saying the melting points of A and B are compared. And then write down the independent variable. What are we changing between A and B? Already you know. We said if chain branch, for you to remember, if chain branch. So is it intermolecular force that is changing? No, they have the same intermolecular force. They all have London forces. Is the chain length that is changing? Yes. Propane, shorter chain length. Butane, longer chain length. So you're able to see that independent is what are we changing? We're changing the chain length. So the molecular mass is definitely different. And then the question will say, indicate the difference. You are able to do that. So as given, define melting point. You are able to define it. And then melting points of compounds A and B are compared. And then we said the independent variable is your chain length. Definitely is a chain length. But even if you said the number of carbon atoms, we will accept that one, or the molecular mass. But it's even much easier when you just talk to the chain length, which is in our exam guideline. Now, explain the difference in melting points of these 2 compounds. You see, that is 3 marks. It's channeling you now to say, okay, you have told us about the different, and then you are going to say, talk to the strength. So always acknowledge the intermolecular force, to say all of them, they have London force. All of them, they have London forces. And then because it's alkanes, all of them, they have London forces. And then you are saying a butane has a longer chain length compared to propane, longer chain length than propane for butane. So you refer to them as B. B has longer chain length than A. And then in terms of energy, more energy will be required. The one that has a longer chain length, definitely it will have a strength of intermolecular force will be high. So which means now you are saying the strength of intermolecular force in B is higher or is stronger. So B has longer chain length, so it has a stronger intermolecular force than A. And then if it's stronger, more energy. Remember, you're going to face a stronger somebody, you must have more energy to overcome the intermolecular force. So always be in that structure, use your dice, always look at what is different. But in terms of intermolecular forces, I will advise you to always acknowledge your knowledge, to know that, to show that you know that both of them have London forces or has dipole, as indicated to say AAA, all of these, they have London forces. Hague, all of them, they have dipole. And then AC, your alcohols and carboxylic acid, they have hydrogen bond. Remember, alcohol have one side for hydrogen bonds, and then carboxylic acid have two sides. So carboxylic acids are the strongest of all the intermolecular force. I hope that will help you as you go on in answering questions. Now, just to complete this question, to say the melting points of compound C and D are now compared. C and D, you can see different functional groups. Definitely, if the functional group are different, we'll be talking about different intermolecular forces. So when you respond to this one, you're going to tell us that, okay, when it comes to butanol, it has dipole. When it comes to butan 1-ol, it has hydrogen bond. And then you come and tell us about now, that is the difference between them. The difference is that the other one is dipole. And then the strength of intermolecular force, the S there for your dice, is to say now strength, definitely hydrogen bonds are stronger. So you are saying D has stronger intermolecular forces than C. And then you are saying because they have stronger intermolecular forces than C, you got the energy required to overcome the intermolecular force. You're saying more energy will be required for D to overcome intermolecular force in D than in C. So I hope that will help you and you'll be able to collect all those marks that you are expected to collect under that question. Organic reactions, already I've emphasized the importance of these three homologous series. Your alkanes, your haloalkanes, you will see when you look at the question, and your alcohols. If you understand these ones, most of the things will be much easier for you because you know, don't forget alcohol, alkanes, haloalkanes, and alcohols. And we are saying these, they can undergo substitution and elimination. So when you see those, you think about substitution or elimination. Remember, in addition to that, for alkanes, they can undergo as well your oxidation, your combustion reactions as well in terms of that one. So you have to always remember that. But in the most important thing, and as well your alcohols, esterification, they can be involved in esterification as well. So you're able to have that. But you know that all, when I see alkanes, haloalkanes, and alcohols, I will know that these two reactions I must think about, which is my substitution and elimination. Now, without wasting time, let's look at your USA. When you have unsaturated forming saturated, we are saying it's addition. When you have saturated forming unsaturated, we are saying it's elimination. And when we are having saturated forming saturated, we are saying it's substitution. And we are saying the condition is everything. When we have CDS here, we are simply saying concentrated is for elimination, dilute is for substitution. And then you definitely have to have that one. Now, let's look at a question. We are given now a haloalkane. Now, already I told you that when you see alcohols, alkanes, haloalkanes, and alcohols, you think about these two reactions, please, substitution or elimination. So you can see that, okay, we're having a haloalkane, depending on the conditions. Remember the condition I said CEDS, CEDS. So you know that concentrated, elimination, dilute, substitution. So already you see that, this is dilute sodium hydroxide. Definitely, this must be dilute, must be substitution. This one is concentrated sodium hydroxide. This must be elimination. So already you know reaction 1 and reaction 2. Reaction 1, because it's dilute, is substitution. Reaction 2, because it's concentrated, is elimination. You see, if you have knowledge of all the reaction conditions, I'm telling you, it will be very easy for you to spot these reactions and to be able to answer the questions. And then you are able to see that that reaction is able to form. We had a haloalkane forming an alcohol. Definitely, during substitution, when we form from haloalkanes to alcohols, we're calling that a substitution, and the type of reaction is called hydrolysis. Remember, we can use dilute sodium hydroxide, or we can use water. It's not only that, it's water and mild heat, because they're going to ask you about the other reaction conditions. So you know, for substitution, we don't want that, we just want mild heat. And then we're saying for hydrolysis, it's either we'll use water or dilute sodium hydroxide. When you're using the concentrated sodium hydroxide, definitely you are going to undergo elimination. Remember, elimination, we are forming unsaturated, meaning that we'll have our double bonds here. So double bonds, compound Q will be unsaturated, definitely. And for unsaturated, you know, USA is only one reaction that unsaturated undergo. So when you see an unsaturated, definitely it must form a saturated, and the reaction is called addition. So you know reaction 3 is addition. Why? Because we are having unsaturated. So we're saying when you see an alkene, definitely you know the reaction that an alkene will undergo is addition reaction. So remember, you have that told you about substitution and elimination. Now we are bringing you alkenes to say when you see alkenes, you know they are unsaturated. Definitely USA, they are going to be saturated, and the reaction is called addition. And you must know the types of reactions, the types of addition, the types of elimination, the types of substitution. Now name the type of reaction represented by 1. Already we talked about that. We said it's substitution, and then that is the type of reaction. And then we'll accept hydrolysis because we are being specific. And then is the methyl butan or 1-ol, is this a primary, secondary, or tertiary alcohol? So you are able to see that it's on the terminal carbon. Definitely that must be primary, because we have seen with propan 1-ol, propan 2-ol. Propan 2-ol was secondary, propan 1-ol was primary. So at least it gives you so that you are able to see that this is a primary alcohol, and the reason you are saying the carbon atom bonded to the OH is bonded to one other carbon, or the OH bonded to the carbon atom, which is bonded to 2 hydrogen atoms. So you can talk about the hydrogen atoms or the carbon atoms. Will accept any of those. So you are fine. Write down the structural formula of compound P, and then you see P is C5H11Br. Now don't make a mistake of thinking that this structure C5H11Br has no branch. Always look there. It's saying 2-methyl butan. So you can see that in carbon number 2 we have a methyl. There's a branch there. There's a side chain there. There's a substituent in carbon number 2. So don't make a mistake when you have to draw this structure. Definitely the longest carbon chain must have 4 carbons. And then that's what we are having. In carbon number 2, we must have a methyl, you'll get 1 mark for that. In carbon number 1, we have a bromo, you'll get 1 mark for that. In the longest carbon, the whole structure is correct, another mark. Just look at the number of marks, 3 marks if you are doing that correctly. So take drawing of structural formulas, very important. Name the type of reaction represented by 2. So you are able to see that 2, definitely we said elimination. So you can see that we're going to eliminate because we're using concentrated. And then you can call it elimination. We'll accept if you are specific to tell us the type of elimination, which is dehydrohalogenation or dehydrobromation. Now, to which homological series does compound Q belong? And then obviously because of elimination, you know it must be alkenes. Now these are alkenes or alkene, it's fine. And then you are able to answer that. And then name the type of reaction represented by 3. So already you have seen we have unsaturated forming saturated. That must be addition. Always when you see unsaturated or alkenes, you know they undergo addition reaction. Write down the IUPAC name of compound R. You are just putting the Br there, so you know that you will have 2-bromo, 2-methyl, 2-bromo, 2-methyl. Remember, you're bringing the bromo there. 2-bromo, 2-methyl butane. Here we're talking to the issue of your product now, to say that your product must be in terms of the rules, to say no. Remember, your bromo will go for the carbon, that the poorest carbon. The poor here becomes much poorer, so you must be able to know that the bromo will go to carbon number 2 because it has less number of hydrogens. And then we are saying always remember cracking as the chemical process in which longer chain hydrocarbons and molecules are broken down to shorter, more useful molecules. And we are saying focus as well on thermal cracking and catalytic cracking. And we are saying the products of cracking is either an alkane and alkene or alkene and hydrogen. So cracking, we can crack at any point. You can see we can crack and remove CH from butane, can remove CH2 and propene there. And then that is the structure. We can crack in the middle and form ethane and ethene. So that is what we are talking about in terms of cracking, and be able to differentiate between thermal, where we're using high temperature and high pressure, and catalytic, where we're using catalyst for the reaction to take place. Now, example of combustion or oxidation reaction, and then the example there we have butane, which is a fuel in our big lighters. I think you have seen the lighters. And then we are saying here it is alkanes plus oxygen to form carbon dioxide and water. The main thing, plus energy. The main thing we are saying, you will get a mark for the reactants, product, and everything is correct. When everything is correct, you will get your 3 marks. So please make sure you do all this and you understand even how to balance. In the event the balancing is not correct, definitely you will lose that 1 mark for balancing, but you'll get 2/3. Now, if we are to focus on question 8 and 9, because we said these are the questions that learners didn't perform well in the past. So you have done electrochemistry, still in your mind. Definitions. Don't forget, we said loss of electron is oxidation, and then it goes with the reducing agent, which is oxidized. So always you are remembering that your reducing agent is a substance. It's a substance that undergoes oxidation, or the substance that loses electrons, and it is oxidized. And then you know reduction is gaining of electrons, which is reduction, and it goes with the oxidizing agent, which is reduced. So you are able to always remember that the oxidizing agent is a substance. It's a substance that undergoes reduction, or a substance that gains electrons. And we are saying, don't forget, you have the anode and the cathode. You must know their definitions. Remember, we said this is the electrode where oxidation occurs or take place. Oxidation occurs at the anode. Cathode is the electrode where. Now, it's not a mistake that we are saying electrode where. So we are not necessarily saying the cathode undergoes reduction. We are saying it's the electrode where reduction occurs. So we are simply saying where the cathode is, there will be gaining of electrons. But electrons are usually gained by the cations, like when you have copper 2+. It's not copper that will gain electrons, it's copper 2+. And then it's very much important that you say it is the electrode where oxidation occurs. We call it cathode. Hence, we are saying an ox and red cat, so that you are always reminding yourself the reducing agent and oxidizing agent. We talked to that. The issue of oxidation numbers. Please, you can answer these questions based on oxidation numbers. And then electrolysis. Remember, this is a process now. It's a chemical process now that converts electrical energy to chemical energy. Please differentiate between electrolysis and electrolytic cell. Please, we are strict when marking this. when you are defining electrolysis, you'll say it's a chemical process, then you talk about energy conversion. But when you are defining electrolytic cell, you will say now this is a cell that converts. You always start from electrical energy to chemical energy. When you talk about electrolysis, it's a chemical process that converts electrical energy. Energy conversion is the same, but the difference is that electrolysis is a chemical process and electrolytic cell is a cell. But both of them, they convert electrical to chemical energy. So always remind yourself of that. Now, I refer to this one as your solution, as the memorandum, the marking guideline. When you are having this one, when you have the understanding of table 4A and 4B, you are well armed for this type of reaction. Remember, this table we are saying is a table of standard reduction potential, which usually will say this is the ability to gain electrons. Remember, reduction is gaining of electrons. So this table shows the ability to gain electrons under standard conditions. And we are simply saying, what are the standard conditions that we are having? Our standard condition is the initial concentration. Not by mistake that initial must be there. It's initial concentration of 1 mole per cubic decimeter. That is the first standard condition. And then the second standard condition is that the temperature must be 25 degrees Celsius or 298 kelvins. If you prefer to use kelvins, it's fine. Temperature is equal to 25 degrees Celsius and pressure is 101.3 kilopascals. Please, if you go to table 4A on the data sheets there, you will see that temperature is given as 273 kelvins. So you have to add the 25 there to get the 298 kelvins when you talk about standard conditions. It means these values are valid under these conditions. But remember, pressure, it applies when you have gases. That's why I would always write pressure as number 3, because if you have no gases, no pressure, that will be a factor. The factors will be initial concentration of 1 mole per cubic decimeter and temperature of 25 degrees Celsius. And then we are saying now, this table is the ability, which means when I look, let me just look at the two. We're having the first cell, half cell, and the second one, Mg2 plus, and aluminium 3 plus there. If you look there, you can see now that we are having this situation. And if you were to look here on the right, there is an arrow. I hope you are having a hard copy of your table 4A and 4B, because you can't go to the exam without it. In the exam paper, you will definitely get a copy of table 4A and 4B. Don't bring it. It is part of your question paper. And then we are saying this is the table that you need when you are dealing with question 8 and question 9. And we are saying, if you look, there will be arrow that is facing upward there. It's saying increasing reducing ability. So we are saying that our reducing agent, when you look for the reducing agent, look up on the right. Reducing agent. So look up on the right, and up on the right, I find the strongest reducing agent as magnesium compared to aluminium. So whatever is at the top there in terms of table 4B is our strongest reducing agent. So I know magnesium is the strongest reducing agent compared to aluminium. So we're saying aluminium and magnesium, they are both reducing agent. But in terms of strength, magnesium is a stronger, because the arrow there is facing upward. It's showing you the stronger reducing agent, because on the right of the table we have reducing agent, whereas on the left we have the arrow of table 4B. We have the arrow that is facing downwards. It's showing you where to find the strongest oxidizing agent. So oxidizing agents are on the left of the table. On the right, we have reducing agent. I want us to move like that. And then I was to ask you a simple question to say, if you are having a company, will you want strongest employees or weakest? Definitely, if you want to have good production, you will want the strongest oxidizing agent and strongest reducing agent in order to have a spontaneous process. Remember, galvanic cell, we are saying this is spontaneous process. So definitely for galvanic cell, our reactions will always be between the strongest reducing agent on the right, which is magnesium in this case, strongest oxidizing agent, on the left, which is bottom left there, you are having copper 2 plus. So definitely, I mean, you are having aluminium 3 plus, if I was to compare these two neighbors so that we don't waste time. So you're having your magnesium and aluminium 3 plus there. And then those must be stronger reducing agent, stronger oxidizing agent. So these two, they definitely form the weaker ones. So which means magnesium is a stronger one, it becomes a reactant, which means magnesium must reverse to form magnesium 2 plus. Aluminium 3 plus is a strong oxidizing agent, which means it must gain the electrons. Remember we said it has a bigger ability. Aluminium has a bigger ability. This number is bigger than that of negative 2,36. So aluminium 3 plus has a bigger ability to gain electrons. Definitely, it's a stronger oxidizing agent. So aluminium 3 plus is gaining electrons to form aluminium. So our product are the weaker ones. The stronger ones on the left, the weaker ones on the right. And you can see by so doing, already we have written the overall cell reaction just by looking for the stronger reducing agent and a stronger oxidizing agent. And for question 8, that's how we are moving. And then with that, we are able to see, even if we say write down oxidation or friction, you can see that magnesium is a stronger reducing agent. Definitely is magnesium is forming magnesium 2 plus, which means it's losing 2 electrons. We are reversing it. And for aluminium, as a stronger oxidizing agent, it's aluminium 3 plus 3 electrons forming aluminium, which means you write aluminium the way it appears there. It goes forward like that. And we are writing only one arrows, not double arrows when we're writing the half reactions. And then if you combine these two, you are able now to say, okay, let's combine. But when we combine them, we're saying ionic. The ions must be balanced as well. So you can see that this has 2 electrons, magnesium. Aluminium has 3 electrons. So the first thing that you have to do is to definitely balance the electrons. So okay, this one with 2, I'll multiply by 3. The one with 3, I'll multiply by 2. So definitely we'll say times 2. You multiply the entire expression. If you're multiplying this by 3, it will say times 3, times 3, times 3. And then for the aluminium part, you're multiplying by 2. You want to balance the electrons, times 2, times 2. So you can see that when you multiply 2 electrons of magnesium by 3, you get 6. So this will be 6, this will be 6. They will cancel one another. And then you are able to write now the overall or the net cell reaction as 3 Mg, balanced one. 3 Mg plus 2 Al3 plus forming 3 Mg2 plus 2 Al. And then that is your 3 marks there. That is your 3 marks. And then after that, we will say write down the cell notation. Look at this. Immediately from your overall, you can see that the anode. Remember, you said we talked the issue of the stronger reducing agent, which is in your anode there. So you can see that we have the anode at the top and the cathode at the bottom. So definitely at the anode we have magnesium. At the cathode we have aluminium. So you are able to see that the reaction that is taking place at the anode, which is the loss of electron, A at the top, C at the bottom. So definitely this table, if you have it, you have all the skills. You are able to say, okay, when I write cell notation, I say A, B, C. When you're writing the half fractions, you said A and C. So you see it's A and C, you start with anode, then cathode. But when you write the cell notation, you are saying A, B, C. You are starting with your anode now, which is your magnesium, or your 3 Mg forming your magnesium. It's magnesium forming magnesium 2 plus 2 electrons. Then when you write this, you'll say Mg. You write the arrow, that is the anode, is Mg forming Mg2 plus. And then you write the salt bridge. Remember, the salt bridge is there to complete the circuit, and then it's important, is there to maintain electrical neutrality. So the salt bridge is important, and then you write now Al3 plus forming Al. So that is our cell notation, ABC. A for anode, then salt bridge, then the cathode, and then you are able to get your marks there. Definitely from there, we'll say calculate the EMF of the cell, and then you are definitely going to calculate the EMF of the cell. In fact, calculating the EMF of cell is simply this one, magnesium, you are reversing it backward. Definitely you're just putting a negative sign there. That's what you are doing when you're calculating EMF, because if you put a negative, it becomes positive, and you say 2,36 minus, if you add these two numbers, definitely they will give you the EMF of the cell, but with the reversed one with the negative sign. But we are always emphasizing to say continue to use the formulas that you are given, which is your E cathode, E of a cell equals to E cathode minus E anode. Don't change the formula, please. Copy it the way it appears in the data sheet. Just go and copy it. You can talk about E of the reducing agent, E of the oxidizing agent minus E of the reducing agent. It's still fine. You can use that formula as well. And you know, reducing agent, you said is magnesium, and the oxidizing agent, you said is aluminum 3+. So you can see that the cathode now is that minus 1,66, which is what E of a cell will be equals to minus 1,66 minus 2,36. And then just using the calculator, you are able to get your answer of 2,36 and 1,66. And then if your calculator is doing well, you'll have 2,36 and 1,66. And then you know it must be 0,7, and your answer must be positive, because we are saying this is spontaneous, which means it's self-sustaining. We don't need external source of energy. It has its own energy, which is enough. So I hope that shows you. And then this is another question that we've given you that you can practice. And then you are having magnesium and copper, and definitely you have seen on the table magnesium there on top of the table there. So definitely on the table you are going to get magnesium 2+ plus 2 electrons given like that, forming magnesium. And then copper, you are having copper 2+ plus 2 electrons forming copper. And then this magnesium was negative 2,36, and copper is positive 0,34. And then you just follow the arrows. The arrows are saying is going upward on the right for reducing agent, is going downwards for oxidizing agent. So you can see the reaction is between magnesium and copper 2+. And then they are forming magnesium 2+ and copper. So you are able to see now the overall cell reaction that you are going to get. You can even be able now to know that the half reactions that are going to take place is magnesium. The magnesium one, you are reversing it. The copper 2+, because it's a strong oxidizing agent, is gaining electrons. So definitely you will have magnesium forming magnesium 2+, losing electrons. You'll have copper 2+, gaining electrons to form copper. And then the overall, as I've shown, the electrons are balanced. So definitely it's your Mg plus copper 2+. What is on the left, you write on the left. What is on the right, you write on the right. And you are able to get your 3 marks there. When you say cell notation, you are saying A, B, C. Your anode, you know, is magnesium, forming magnesium 2+. Your salt bridge is double arrows. Your cathode, you are having copper 2+, forming copper. Say, am I right if I indicate the concentration of the ions there of Mg2+? Yes, initial concentration, we said is 1 mole per cubic decimeter. So you can show it, it's fine. Am I right if I show the phase is solid and aqueous? You are very right. So you can copy them with the solids and the aqueous with the concentration is right. But even that one will be able to get your 3 marks. And then you can be able to calculate the EMF as well, because you know we're saying E cathode, E of a cell equals to E cathode minus E anode. So definitely you are able to do that. And then your cathode, always the bigger number in terms of this one. The cathode is always bigger, which is your 0,34 minus your anode. In this case, is negative 2,36. And then you just do your signs. I think you will get 34 plus that is 70. You'll get 2,70 volts. So you are able to do that. You can confirm that with the calculator. 0,34 plus 2,36. definitely is 2.7 volts that you get. So if we look at all these questions, they are asking all that which I was doing here, and I've demonstrated to yourself to say this is how you go about answering some of those questions. Look at this question. It says, how will the concentration of Mg2 plus, is a plus there, how will the concentration of Mg2 plus ions be affected when the cell is functioning? So you are able to see that now as the cell is functioning, magnesium is losing, because magnesium here is alone, is 0. It's forming magnesium 2 plus here when it's magnesium nitrate like that. So magnesium is forming magnesium 2 plus because we said it's a stronger reducing agent, it's a reactant. So it's forming that. Definitely the concentration of magnesium 2 plus will increase because it's busy losing that. But when you go to the cathode side, you will find that we have copper 2 plus that is gaining electrons. So definitely the concentration in the cathode of metal ions decreases. So this concentration will decrease, this one will increase. But in this case, the question was about concentration of magnesium 2 plus, which definitely will increase. It will increase, while the concentration of copper 2 plus will decrease. And then they asked a question there that says the cell is connected to a light bulb. In theory, the bulb should light up, but in practice, it does not. What can be the possible reason for this observation? Remember, the light bulb has what? Resistance. And you will find that the current that is being supplied is low. So when you have low current and the resistance, high resistance and low current, definitely the light bulb won't light. So you are able to explain that and be able to do that question. Now, if we look at electrolytic cell, remember now, I want to emphasize this one with electrolytic cell to say, remember we're doing four types of cells here. You are doing now refining or purification of copper. As an example, can be purification of any metal. You are doing electroplating, that is number 1, is purification or refining, which is what we have here of metals. Number 2, we are saying we can have electroplating. Number 3, we're having now decomposition of copper chloride solution. And number 4, we're having electrolysis of concentrated sodium chloride solution. So those are the 4 processes. And without any wasting of time, the understanding here is that during purification, it is the metal that loses the electrons to form the metal ions. And then in this loss of electrons is at the anode. In the cathode, always we are writing the reverse reaction, which is the same reaction but in reversed order. So I hope you get that one. And then we are saying in terms of the same happens in electroplating. The object, the metal that we are having, will lose electrons. And then on the cathode, the metal ions will gain electrons like that. And then that's what is happening during purification and electroplating. Hence, we are saying the concentration of the electrolyte remains constant, remains the same. Why? Because the rate of oxidation is equals to the rate of reduction. So that's what we are having in terms of this particular cell. And then write down here, they said define the term electrolyte. Remember in these processes we are having salt, which is our compounds that are now when we put a salt in water, it will definitely form iron. So here we're talking about the substance that dissolves in water to give a solution that conducts electricity. You write it as is in the exam guideline, or the substance that when dissolved in water, it contains ions. It contains the ions. That is your electrolyte. So, and then write down the formula of the cations in the electrolyte of the above. When the write down the formula of the cations. Remember, we're having copper. is purification of copper. It means we have copper and another copper. And definitely the cations is the positive ions, which is the copper 2+. So that is 9.2. When an electric current passes through the electrolyte, the mass of the electrodes changes. That's the mass of electrode X. So you are able to see X. Remember, we are saying positive, the bigger one. Positive is anode. Positive is anode. The bigger one is anode. Negative, the small one, is cathode. Don't panic. So positive is the anode. That's where X is. And we're saying an ox. Where anode is, there will be oxidation, which is loss of electrons. So the expectation here is that here we're going to have loss of electrons. Definitely, does the mass of electrode X increase or decrease? Definitely it will decrease, because X definitely is going to lose electrons. And then, which is copper, because our X is copper, that is copper will lose electrons. So when it loses electrons, it will definitely decrease in mass. It will decrease in mass because there is loss. At the anode, we are losing electrons, then there's decrease in mass. And remember, on the cathode side, the copper 2+ will be gaining electrons, which is the reverse of this. On the cathode side, the copper 2+ will gain electrons to form copper. Then we're expecting this one to increase in mass. We're expecting this one to decrease in mass. So X as the anode, it will decrease in mass. Write down the relevant equation to support your answer. I've already written copper forms copper 2+ plus 2 electrons. So you are able to see that now. These type of questions, you can see they are there to stay, where you have to deal with calculations. Now they are saying the diagram below shows an electrochemical cell used in the refining of copper. Now, during the process, it is illustrated by the above cell, a total of 2,259 times 10 to the power of 24 electrons. You see, it's important to always know those formulas in your data sheet to say, okay, when I'm given mass, I will definitely use this formula to calculate number of moles. When I'm given number of particles, the particles can be electrons, protons, ions. When I'm given number of particles, I will use N equals to N over Ne. Definitely, here we're given number of electrons. You can see we are inviting this equation. Number of moles equals to number of particles, in this case, number of electrons, over Avogadro's number, 6,023 times 10 to the power of 23. So you are able to see that you are going to definitely need this to get the number of moles. But what I want to emphasize is that, remember, you are talking about electrons. So we must have what is called mole ratio between the number of electrons. Copper is going to form 2 electrons. Definitely, the mole ratio between copper and the number of electrons, definitely 1 copper produces 2 electrons. So the mole ratio is 1:2. This is very important in your calculation. And then, without wasting time, definitely you're going to say, I'm given the number of electrons. You substitute the number of electrons, and then you substitute the Avogadro's number, and then you are going to get your answer, which is 3,7525. And then you are going to use the mole ratio to say, okay, for 1 mole of copper, I have 2 electrons. So I must definitely divide here by 2 to get the number of moles of copper as 1,876. So that is the number of moles of copper. Now I can use the number of moles of copper to calculate the mass. You know, number of moles equals to mass over molar mass. The molar mass of copper is 63.5. When you multiply it by the number of moles, you get the mass of copper, which is 1,19. And if you check, this question is mostly there. In most of our questions, you are getting this type of questions. Sometimes they will ask you to calculate current. So all the time, practice this type of questions, because they are there to stay, and definitely you cannot go to the exam without knowing. And then, as we conclude our lesson, I want to emphasize on the stoichiometric calculations to say, always remember this table. It will help you a lot, your data sheet, to always know when we're given the mass, we're going to definitely use that formula. When we're given the number of particles, in this case, we're given number of electrons, we're able to use this to calculate the number of moles. But when you're given concentration to get number of moles, definitely you will use that And then as well, you can use the C equals to M over MV. But now, when we are given the standard conditions, STP, standard temperature and pressure, definitely molar volume. Sometimes you'll just be given molar volume. Remember, we had our molar volume at 22,4, the one that we're using at 0 degrees. But for example, when you are at temperature maybe of 25 degrees Celsius, the molar volume will change. It can be 24 cubic decimeters. So always check those conditions. Sometimes you'll be given the molar volume. So when you see molar volume, you know that the formula that you must use is that one. So you will be looking for STP, you will be looking for molar volume on different conditions. Then you will definitely use that. And if you are able to use these equations, we are saying if you know the moles of A, because most of the time you are given information based on reactant A, but you are going to use that information, or on the product you are going to use the what you are given to get what you want. So the only way to move from what you know or what you are given to get what you want is to get the number of moles. After getting the number of moles, you are able now to cross the bridge to use what you have to get what we have using mole ratio. So mole ratio is of paramount importance as long as you are dealing with your stoichiometric calculations and wanted to talk to the issue of percentage purity, to say, remember, we are saying that pure mass divided by impure mass times 100 will give you percentage purity. We gave you example here when we have 5 grams of sodium carbonate, and then we find that the pure one was 4,25. You are able now to calculate the percentage purity as an example, to say, you will say the pure mass divided by total mass, which is the impure mass, times 100, and then you are able to get your percentage. And rates of reactions, we are still emphasizing there to say, remember the definition of reaction rate, which is the change in concentration of reactants or products per unit time. Definitely, you know the reaction. When you see that the reactants are decreasing, you see that this is the graph of the reactants, because when we start the reaction, we're always starting with the reactants. The products are increasing as we proceed. So you are able to see the graph of the reactants and the graph of the product. So you are able to see that and you won't have problem. And then you are able to know that when given the heat there, you know it's exothermic. When the heat is added, it is endothermic as well. And then the importance now of the graphs, to say we have here the reaction where we have slow reaction and fast reaction in red there. So you can see the steeper the line or the steeper the curve, the greater the rate of reaction. And faster reactions where the line becomes horizontal finish sooner than slower reactions. But you can see at the end they are ending at the same point. But you can see that there is a factor here. When we increase the factors, definitely the rate of reaction increases, the graph becomes more steeper. So it's important that you have that knowledge. And we are saying always remember collision theory. And remember the Maxwell-Boltzmann distribution curves for the temperature. We're drawing there for Cape Town for concentration, pressure, and temperature. Remember, with temperatures, we are saying now what happens, the particles will definitely move, because when we increase temperature, the graph will definitely, it will shift to the right. So it goes down and then shift to the right. So you are able to see that the graph of temperature, it touches there. Be able to draw these graphs and then see that how to use collision theory to explain this. We are always indicating the most important points to say when you increase temperature, you increase the average kinetic energy of the particles. That is the first point that you know. And the second one, we're saying we're going to have more particles. We're going to have a more effective collision per unit time. Please write it in full. You write put like that, you won't get any mark. It's more effective collision per unit time. I'm summarizing for you as we conclude the lesson. Now we are saying more particles now, because now you see there's a shift in terms of the graph. You have now more particles that will have energy greater or equals to activation energy. So you increase the number of particles that have energy that is greater or equals to activation energy. And definitely because of that, we're going to have the increase in rate of reaction. So that's how you answer questions like these ones. So for the temperature, we're saying our graph now is going to shift, but it bends downwards, then it shifts to the right, and it touches the original graph, and then you are able to see that we have all that. And then don't know only for increasing the factor, you must as well know about when we decrease the factor. Definitely we'll have a decrease in the average kinetic energy of the particles. We'll have less or fewer effective collision per unit time. We'll have less particles with energy greater or equals to activation energy, will decrease the rate of reaction. So know both for increase and decrease when you are dealing with these graphs. And then in terms of concentration, it definitely is on top, because when you increase concentration, you are increasing the number of particles per unit volume. Number of particles, we're talking about it now. Number of particles per unit volume. You're increasing the number of particles per unit volume. Just write in English. And then more effective collision per unit time. And then we are saying we'll have more particles that will have energy or kinetic energy greater or equals to activation energy. And then we are saying you will increase the rate of reaction. Please have understanding, write in full, and then be able to collect these marks. And write in bullet form as I'm indicating, so that you can see that for temperature, the other three bullets are remaining the same. I just changed the first bullet there to say for concentration, now it's no longer now going to touch. It will be on top of the other graph. And definitely it means when we increase concentration, we're increasing the number of particles per unit volume. Now when it comes to the catalyst, now you can see the catalyst, what it does. It provides an alternate pathway. It provides an alternate pathway of lower activation energy. So that's what the catalyst will do. So it lowers the activation, which means it's going to accommodate many particles. Remember, we're having particles here: A, B, C, D, E, F, G, if I'm to represent particles like that. So if you are to lower activation energy, you are accommodating more particles. So it provides alternating pathway of lower activation energy. The other bullets, there will be more effective collision per unit time. Now you'll have more particles that will have energy greater or equals to activation energy. You'll have now increase in the rate of reaction. So even the catalyst does that. The difference is that the catalyst goes inside, the temperature shifts to the right and touches. The concentration is on top of the original graph because we're increasing the number of particles. So you can see it is concentration that increases the number of particles per unit volume. The temperature, the number of particles remain the same. Now, just to look at an example of a question, to say you have 2 H2O2 there forming 2 water liquids plus oxygen. And they are saying in this experiment A, B, C, you can see the temperature there, 25, same condition. But the reaction experiment A is without catalyst, experiment B is with catalyst. And they are saying in which experiment, A or B, is the reaction rate higher. So you are able to see that, okay, temperature is remaining constant, so it's a controlled variable. But what are we changing? No catalyst with catalyst. So immediately when you add a catalyst, you're going to have a higher reaction, which is experiment B. So you're able to choose B as your experiment. Now use collision theory to explain. So you're going to say a catalyst provide alternate pathway of lower activation energy. Bullet number 1. You're going to say more effective collision per unit time. You're going to say more particles will have energy greater or equals to activation energy, and we're going to increase the rate of reaction. So that's how you will answer, and you will get your answers. And then definitely you will get a question on chemical equilibrium. Just wanted to emphasize here to say, as you revise, look at chemical equilibrium. Remember, we said it's a dynamic equilibrium where the rate of forward reaction is equal to the rate of reverse reaction. We said there are only 3 factors here that we are looking at that are affecting rates of reactions. It's your capital, so concentration, pressure, and temperature. Remember, rates of reactions, they are affected by about 6 factors there. We said now is your temperature, is your pressure, is your concentration, is your surface area, is your nature of reactants, and the catalyst is number 6. So it's 6 factors for rates of reactions, it's 3 factors for chemical equilibrium, and then understand how these factors affect the rate chemical equilibrium. Now, as well, remember Le Chatelain's principle as well. You definitely have to know Le Chatelain's principle, how to state Le Chatelain's principle, and be able to look at the graphs of rates and concentration. And then definitely you will do that. Remember, you have done the graph of endothermic and the graph of exothermic, where we are saying here the energy that is absorbed, that is the activation energy, which is the minimum energy required for reaction to take place, is less than the energy that is released. So you can see we had activation energy there, but the energy that is released is small. Hence, we are saying this is exothermic, and the second graph here we are saying is endothermic. So be able as well to revise your grade 11 work and the definitions that goes with it. And then here we wanted you to look at the 2 graphs that are showing both the chemical equilibrium. To say it's it's a dynamic equilibrium where the rate, so the 2 graphs on the reaction rate, they talk about the rate, which is this one is the forward reaction and reverse, and we're saying the rate of forward reaction is equal to, hence the 2 graphs become one there. But when we talk about concentration, we're saying the concentration of the reactants and the concentration of the product remain the same. We're not saying they are equal, we're saying they remain the same. So revise that as well and do the questions based on chemical equilibrium as well. Remember, the most important thing that we looking at is your rise table. Be able to rise. Don't write rise only. Show that the R is for the ratio, I for the initial number of moles, C for the change in number of moles, and E for equilibrium, and indicate the concentration as N over V in moles per cubic decimeter as indicated there, so that you are able now to get all of that. And then we are simply saying you have marks that definitely you can't live without. We are saying always at equilibrium, you will take the number of moles at equilibrium, you will always divide that by volume and get your 1 mark. That is the mark that you have. And then the mark for the ratio, to say as you are given NH4Cl, NH3, ACl, definitely the change there must be in that ratio. So you must be able to get the mark for the ratio. You must be able to divide by your volume. You must be able to write the Kc expression. And we are emphasizing that as you write the Kc expression, ensure that at least you are writing, we're given a NH4Cl solid, NH3 gas, and ACl. You know the concentration of solids and liquids, pure liquids, is 1. So definitely you will include the NH4Cl. You will just write 1 for that. So hence we are saying Kc, the product is NH3 multiplied by ACl, which is what is written here. You get 1 mark for that. And then you substitute the concentration at equilibrium, and then you are able to do your calculation and get the mark. So if there are marks that definitely you must get, is the mark of the ratio. Remember, on the product side you are adding, on the reactant side you are subtracting. You must be able to divide by your volume. You must be able to write the Kc expression and to substitute on that Kc expression and get your answer. And definitely that is going to help you as you deal with these questions. You will deal definitely with the graphs of equilibrium. Remember, in terms of the factors, you are able now to remind yourself to say, if I look at T1, I can see that what is happening at T1, you can see that N2 here is the one that is rising up. And then you are able to see then that here it shows that there is now increase in concentration of N2. So N2 was added there. We are having equilibrium. When you add N2, equilibrium is disturbed. And remember, if we increase the concentration of a reactant, definitely the forward reaction will be favored. The forward reaction is NH3, so you're expecting NH3 to increase, hence it's increasing. It shows that the forward reaction is favored. And when we increase N2, the other reactant must definitely decrease, which means now we're expecting H2 to gradually decrease. And then when we have both all our species, our reactants and products, all of them are increasing here, and that is pressure. So when we increase pressure, the concentration of the reactants and product, all of them, their concentration will increase. So don't forget, for the equilibrium graph on concentration, when you increase pressure, you definitely expect that everything must increase. Remember, when you increase concentration of the reactants, you only that concentration is increasing. But when all of them increases, you know it's pressure. When all the concentration decreases, you know it's pressure. So when you increase pressure, all the concentrations will increase. When you decrease pressure, all the concentration, which is what is happening at T2, we have increased pressure there. And then if you look at T3, there is no sharp increase in terms of our reactants and products. Then you know it must be temperature, because temperature does not affect the concentration. So the concentration remains at the same place, but now it will only depend on whether the temperature was increased or decreased. You can see that our NH3 there, which is the forward direction, is this one, is decreasing. So you can see that what is increasing is N2 and H2, which are our reactants, which means we've increased temperature. Remember, if we increase temperature, endothermic reaction will be favored, intermendo. If we decrease temperature, exothermic reaction will be favored. So I hope you have seen, when we increase the concentration of N2 sharply increases, and then the other reactant, which is H2, decreases, and we see the forward direction being favored. The same you have seen at T2, when we increase pressure, equilibrium is disturbed, but all the species or all the reactants and products, their concentration increases, and then we know that is pressure. At T3, we're saying the concentration remains the same, and it's temperature because it does not change the concentration. However, the reaction, according to the Electrolysis principle, will be able to respond to the disturbance. The last topic, as we close, is acids and bases. You will definitely deal with all the definitions that are expected under this topic. We have our Arenas model. Remember, Arenas, he said an acid is a substance it produces. In fact, just go straight to it to say acids produce hydrogen ion. So you're just saying acid produce hydrogen ion in aqueous solution. So in aqueous solution, it produces hydrogen ion. A base produces OH minus. You can just write it like that. A base produces OH minus in aqueous solution. So you just write like that. The issue of conjugate acid and base. Remember, we are saying the difference between a conjugate acid, between the acid and its conjugate base is a hydrogen ion. So they look the same, the difference is hydrogen ion. The one with more hydrogen ion is an acid. The one with less is a conjugate base. The example there being H2SO4 and HSO4 minus. You can see H2SO4 and HSO4, when you look at them, they look alike. The difference is a hydrogen ion. So we're saying the one with more hydrogen is your acid. The one with the lesser hydrogens is your conjugate base. So you must be able to identify the acid and its conjugate base as well, and the base and its conjugate acid. Now, as well, you have done your Lowry-Bronsted model. An acid, proton donor, a base, proton acceptor. You can't go to the exam without knowing that. You have talked to the issue of strong acids and weak acids, because you got to know that strong acids, we are saying they ionize completely in water to form high concentration of hydronium ion. And then the weak acid, they ionize in completely. The difference, strong ones is completely, and the weak ones is in completely. And then the strong base dissociates. So we're just using different ways there. It dissociates completely in water, strong base, and the weak base will dissociate in completely in water. And don't confuse a strong acid and a concentrated acid and dilute acid. Remember, an acid is strong or weak, but the strong acid can be dilute or concentrated. So you must be able to differentiate that to say, okay, strong acid, it ionizes completely in water to form high concentration of hydronium ion. But now, when you talk about dilute and concentrated, you are simply saying that we have more number of moles per unit volume. So you have more of a substance per unit volume of water. So you have more number of moles of a substance in proportion to the volume of water. So when you have less water added, that is concentrated. But dilute, it means we have more of the water. So you have less number of moles of a substance in proportion to the volume of water. That is dilute, when you have more water than the substance itself. But when we have more number of moles of a substance in proportion to the volume of water, it's concentrated. And we're saying a strong acid can be concentrated, it can be diluted. So concentrated, it depends on how much water it has, and dilute as well. When it has more water, it's diluted. When it has less water or no water added, it's concentrated. And then the last part is the issue of your hydrolysis. Remember, we're saying is the reaction of salt with water, and you must be able now to show whether the salt is acidic or basic salt using the process of hydrolysis. And then you will look at the issue of neutralization reactions, and then be able as well to understand that when you are having a strong acid reacting with a weak base, the solution will be acidic. Remember the issue of the choice of indicators, which in this case will be your methyl orange. And then when you are having a strong acid with a strong base, you will have a neutral solution. And remember, you will be using bromothymol blue. And then when you are having a weak acid and a strong base, your solution will be alkaline or basic. Definitely, you're going to use phenolphthalein. So I always say MBP so that you don't forget. Methyl orange, bromothymol blue, phenolphthalein. And then you are indicating when the solution is acidic, it means strong acid and weak base. And when the solution is neutral, strong and strong. When the solution is basic, strong base and weak acid, definitely the solution will be basic. You use phenolphthalein. And we always indicate the issue of color changes. Look at that to say when we have acidic solution, we're going to have a red to orange. And when we are having a neutral solution, we're going to have yellow to blue. And then when we are having basic solution, we're going to have colorless to pink. So know those color changes, know the choice of the indicator, which indicator do we use when, and know how to use the neutralization in terms of your governor equation, CA/VA over CB/VB. When you're doing your titration, Na over Nb. Remember, Na and Nb are the number of moles given in the balanced equation. So definitely, when you are dealing with titration, neutralization reactions, your titration calculations, you are going to look at that equation. It makes it much easier. And we are saying when you are given these volumes, use them the way they are given. If they are given in cubic centimeter, just use them because you are having volume in the numerator and denominator. They will definitely cancel one another. You don't have to convert your cubic centimeter to your cubic decimeter. Only when you are using the C equals to N over V, you'll have to first do the conversions. But when you're using the governor during your titration calculations, definitely you will use that equation as it appears. And lastly, pH calculations. Remember, we're saying pH equals to minus log H3O plus. Always remember that you have to first find the concentration of the acid. And then if you are given a monoprotic acid like HCl, you know the ratio between H3O and HCl is 1:1. So the concentration of the acid, you just substitute it there. But when you are having a diprotic acid like sulfuric acid, H2SO4, definitely you're going to multiply the concentration of the acid, the H3O plus, you're going to multiply it by 2 because 1 H2SO4 forms 2 H3O plus. So always look at the ratio of the acid to the H3O plus. So if you are given the concentration of H2SO4, definitely you're going to multiply by 2 because it forms 2H3O plus when you're doing the pH calculation. And if you are given pH, know that you can use the H3O plus is equals to 10 to the power of minus pH to calculate the concentration. And then I will have made a mistake if I leave here without talking about the Kw, the ionization constant of water, which is your H3O plus multiplied by the OH minus, which is equals to 1 times 10 to the power of minus 14. So this one we are saying, please always, when you are given the concentration of the base, you can start here. Come and substitute the concentration of the OH minus in order for you to get H3O plus, so that you are able to move back to go and calculate your H3O plus. That is the summary that I came up to ensure that you are ready as you prepare for your exams. I want to say, as I conclude, when the questions seem endless and your notes look like a foreign language, pause and remember, every reaction you write, every mechanism you solve is another piece of the puzzle falling into place. You are not just studying chemistry. You are training your mind to think critically, solve problems, and change the world. Keep going. The molecules may be small, but your purpose is massive. Thank you. I always close by saying, anyone who has never made a mistake, has never tried anything new, continue to do those calculations, make many mistakes over the weekend, but come the exam time, go and pass and show yourselves. Thank you very much.